Hello, my name is Nathan Lang, and this is my project on DLL injection. This is for the course Computer and Network Security, CSAT 4850, and it is the final project. To start off, I'll give a basic introduction on DLL injection. DLL injection is the process of injecting a DLL file into a process while it is running. The areas that this is used are mainly for the purpose of malware and viruses and in video game cheating and hacking. The reason that this is a big deal and it's an important topic is that if people weren't paying attention to how to stop it and people weren't studying this topic, it'd be a vulnerable area where many different malware and hacks and video game cheats could slip through and wreak absolute havoc. Moving forward, to understand the basics of DLL injection, it helps if you understand the underlying concepts behind what it is and how it's possible. For the scope of my project, I'll be simply referring to the Windows operating system. The first concept that we need to understand about the Windows operating system is how it handles processes and the API that it has that is used in terms of DLL injection. Each process within the Windows operating system has a virtual address space. The virtual address space is a set of ranges that are available to the process. This virtual address space is the area in memory that the DLL injection targets in order for it to be carried out. Each process also has a collection of threads. These threads run in the context of the process, and they're basically just a way for the operating system to allocate what it should spend its time processing. Each process also has a set of handles. There's a handle that holds an integer value, which is the process's ID, and it also has handles for many of the things within inside the process. The reason that these are all important is that within the Windows API, there's many different functions that you can call that use the handle to the process and handles made up of from the functions that can be used to help with the DLL injection. One of the most noteworthy functions within the Windows API is the load library function. This is sort of the main goal of the DLL injection, is to make it to this function and have the process call this function with a parameter that contains the path to the DLL file. Once it runs this function, it'll load the DLL file and the code will be injected. Another important concept to understand is what a DLL file actually is and how they are used. A DLL file is a dynamic link library, and it's made up of functions that other programs can call whenever they need them. These files don't run on their own, and so they are different than an executable file per se. DLL files are used for many different reasons. One of the most powerful uses that they have is that they can be called from many different programs at the same time. This makes them special in the sense that they are good for allocating memory and are very efficient. One of the most notable DLL files is the kernel32.dll. It has access to anywhere on the computer, and the functions that it holds are very powerful. It can be used to work with other programs and other processes. DLL files are powerful for a reason. They were not created to be injected, and they were not intended to be used as a hack or as a malicious attack. The reason that they are so powerful is that they play a big role in the development of programs and allow for many good things to happen. Some examples of these things include resource sharing and memory conservation. They also allow programs to have the ability to be modified by an outside source. This is good when intended to be. An example would be a piece of legacy code that people didn't have access to the source and they needed to change the way that it worked. They can inject a DLL file and go in and alter how it works. Lastly, some people create their programs with them being altered in mind. A lot of times, other people can do things to make the program better, and they can use a DLL to do that. The process of DLL injection can be as complicated or as simple as you want to make it. The most simple version is a basic 4-step process. Attach your program to the process, allocate memory within the process, copy the path to your DLL within that allocated memory, and then execute a function that loads your DLL into the process. A simple way to attach to the process is using the open process function from the Windows API. This returns a handle that contains a handle to the process. It uses the parameters of the desired access, which in the terms of DLL injection, you would want something such as read and write, a handle, and a process ID. The process ID is the ID to the process. Once your program is attached to the process that you want to inject your DLL into, you then need to allocate memory within that process. This can be done using the virtual allocate ex function from the Windows API. This takes a handle to the process which you created with the open process function, an IP address, a size that you want to allocate, the type of memory that you're allocating, and a protection. Once you have memory allocated within the process, you then want to write to that allocated memory so that you can store a value that contains the path of your DLL. This can be done with the write process memory function from the Windows API. This takes a handle to the process, which we got with open process, a base address, which is the base address of the memory that we allocated, a buffer, the size that we're writing, and then it returns the number of bytes written. Once you have the path to your DLL written to the allocated memory within the process, you then want to call the create remote thread function from the Windows API. This takes the handle to the process which we have, security attributes, thread attributes, stack size, the start address of the memory that you want the thread to start at, parameter, the creation frags, and the thread ID. When the create remote thread is ran, it's ran with parameters so that it starts at the address of the load library function. It also uses the parameter that we wrote to the allocated memory within that load library function to load our DLL file into the process. Once the DLL file is injected into the process, the capabilities that DLL file has are endless. An example of the capabilities that the DLL file has would be something such as overriding functions. The DLL file could call one of its own custom functions whenever a function in the process is called and overwrite what that function was supposed to do. You can also do things such as logging data. You can store data from the DLL every time that a certain function is ran or whenever you wanted it to. If your DLL file contained malware, once it was injected into the process, it could then make calls to that malware to do things such as track your keystrokes, steal your information, and much more. If your DLL file was injected into a video game, it could do things such as alter the memory within that video game. The reason that this is a big deal is that it gives players an extremely unfair advantage. It can give them things such as knowing the memory location of where the other players are stored on the map, and then drawing that information to a screen, known as an ESP. It can do things such as give the player infinite health. It can overwrite the function to reduce a player's ammunition every time he shoots, to instead make him gain ammunition every time he shoots. It can let the player fly, and it can give them an unfair advantage that lets them win the game. There has been huge lengths that have gone to prevent things such as DLL injection. Within any antivirus and within any video game that has any sort of security, there will be code in place to monitor and try to prevent the DLL injection attacks. This results in a constant cat and mouse type scenario where the attackers are always trying to find new ways to hide from the security professionals. They try to hide their DLL injection attacks so that they can't be detected and they can run their cheats without the security detecting them. This also works in the sense of people trying to infect computers with viruses and malware. They're constantly trying to find ways that aren't detected by the antivirus programs. One of the ways that antiviruses and anti-video game cheating programs have stopped DLL injections from happening include things such as locking down threads to that process. They know what threads are supposed to be called and supposed to be existing on that process. And so when a DLL injection attack occurs and a new thread is started to call the load library function and load the DLL, they can detect it and prevent that from happening. Another way that it is controlled is through handles. When the DLL injection attacks a process, it needs to create a handle to that process. Anti-cheat and antivirus programs will monitor the handles to the process that they're protecting, and if they find a handle that isn't supposed to be there, they can detect that something is going on and stop the attack. Also, they use the signatures of the DLL files to detect when they are loaded within the process. Every file on a computer has a unique signature that makes up the contents within that file. When a DLL file is loaded into a process's memory, the signature of that file can be detected by an antivirus or anti-cheat program. This is mainly used when a cheat or a malware is massively distributed and they've found one version of it. They can then use that version signature to search for that signature that they found in the processes, and if they can find it, they know that it's not supposed to be there. In conclusion, it's important to understand why DLL injection is and was a big thing. In a lot of places, it's detected completely and it is not used as commonly anymore. This is a big step for security professionals because every time they shut down one way to cheating, the cheaters and the attackers have to find a new way to do it. It's also important to know that there are ethical uses within DLL injection. A lot of times they can be a last resort that saves a legacy piece of code or helps extend a product and give it more features. Thank you for listening to my report on DLL injection. Following are the works cited from my project.